In this video, I'll show you what happens if I do the settings of the transient, if I activate this transient here in this simulation. Before that, I did the DC operating point. If this is still here, I can also see the node voltages of the circuit. So now I'll just activate the transient. In transient analysis, we usually want to see that how the storage elements are behaving, how they are charging and discharging, and how long they are taking to charge and discharge, for example like capacitor and inductor. But now I can see the thing which is of interest is not just the stop time here. There's also two further options here. This is time to start saving data. You can give a reasonable value here, or maximum step size. Step size is usually required if your simulation results are not so smooth, the waveforms are coarse, or they are not, they have some linear interpolation, there are some sharp edges, so you want to make them smooth, so you can increase the step size. It will increase the data points. So right now we are only interested in the stop time. I'll take any arbitrary value. You can take any value, maybe 1 second, 10 seconds, but for the sake of simplicity, I'll take 10 milliseconds. So no need to write the milli here, seconds here, and it is understood it is time. So you can see that this is the transient, this dot transient, and 10 milli, and if there are any option chosen here, they will be appearing here. So this is the transient directive here, and if I place OK, click OK, then I can place it anywhere. So I'll just place it somewhere that I can see that it is, I've configured the transient settings. So now if I run the simulation, we'll see what happens. Now I'm getting a different result as compared to the previous option, which was the DC opt operating point. And that only gave, I can still see those values here. You can see, I can see this node voltage here. I can still see in the status bar here, I can see the node voltages. This is ground, this is 0 volts. And with respect to this 0 volts, so this is node 1, this is the same node. So I can, if I click it right now here, because of the transient analysis, all the settings are the calculations are done, so it will also give me the waveform. There is nothing here in this window, so if there's this red probe here, that means I'll get the node voltage. So you can see it's 10 volts. I can also click here, and definitely I'll see a 5 volts, because at this node there was a 5 volts, and this is down here. 0 has shifted downwards, so this is 5 volts. And if this is understood, it's 0, so that's not showing me. So I can also, if I hover the mouse over these circuit elements, I can also plot their currents. So these two currents are same. So if I place a current here, usually for different parameters like voltages and currents and power, we need different these different windows. But in this case, the LTspice is giving me another y-axis, and if a particular waveform, I don't have a legend here. Legend means that I can just see this. The name itself is referring to what it is. So this is the current in R3. So in this branch here. So if I place the current, if I click this, so you can right click. I have right click it. You can see its name. You can change its color. You can add something to the cursor. I don't know, first, second, whatever. So you can also delete this trace. This is known as trace in LTspice. The graph is usually, the name for the graph is actually a trace. So place cursor on this trace. So you can see, if I use this option, place cursor on this thing, I have this. There's also subscript 1 written here. So if I place it for some time here, you can see there's another window has appeared. You can bring this window in somewhere in where you want it convenient. So this is convenient for me here. So I can now, when I have this mouse here, If this is here, I can do anything. I have to zoom. I can zoom in, zoom out, and this is again, this is for just a normal view where it was before. So now if the mouse changes, I can place it left and right, and you can see that the current, this is showing me the current in R3, and the cursor is showing me no transients. Since there are no storage elements, I can see transient, or even I cannot see a rise time or fall time for this ideal voltage source. So and you can use this one. If I want to see two waveforms and I want to hover them, so I can right click here. Okay, if I click right click here, then I can also place cursor on this trace, so the second cursor will appear here. You can see now the subscript have changed. They have a cursor 1 which is showing you the horizontal is actually time, and the vertical is the 5 volts. Similarly, cursor 2 is not selected. I think I have to click the second cursor. I can't see this. Okay, the other option nothing working, so I'll just click it again, and now I can see that it is activated. So I have to click it on this graph. So now this tells me that this 2 means that now my mouse will show me the values on the cursor 2, which is actually the voltage on node 2. It is so there's nothing new information here because this is a DC circuit. So in all times you can see if I change the time, nothing is changing. So I lost the cursor, so can just click again, and where's the cursor now? Okay, and let's do it again. Let me see where's the cursor. Cursor is somewhere. This is one. Okay, I'll hover the mouse on this window. Maybe I find the cursor somewhere here. No, it's not here. Okay, this is here. This is 2. If I place the mouse over this, the 2 means the 2 is telling me that this is cursor 2 is the voltage at node 2. Okay, these they are both same, so I'll just click one of them is I need a different. So now this is highlighted, so I think the current in R3 is actually cursor 1, and if I still cursor 2, if I place over this one, so whichever is changing, that is telling me this one. So it means that if I place the mouse as 2 is highlighted, so now it will change the cursor 2 values, but if I place it here, now it will change the cursor 1 values, or it will not change the values, but it is actually showing me wherever I am interested in, and I can place this at that particular time. I can find the value, but since there is no information here because it's all the same here for all the time. So this is about the okay. You can also sometime if there is some slope here, you can also find the slope because the slope is change in y over change in x. So these are the y values. So the difference now, because they are different quantities, it will not, you can't tell me there is no sense for the slope here because the difference is in they are two different waveforms. But if there is a single waveform, you can also find the change in y over change in x, and change in y over change in x will give you the so this is change in x and this is change in y. So change in y, rise over run, so to speak, will give me the slope of that curve. So if you want to find the slope in any case, but in this case the slope is in fact 0, but there's no also the waveforms are different. This is current waveform, this is voltage, so the change in y is not making any sense here. So that is about the transient. So if you activate transient analysis, you will get the time waveform, and you can use cursors and hover around different values, and you can see that now the green one is activated because there's some dash line here. You can also change the width of by clicking it right. You can also add trace directly if you want something. If you click this, some other traces will also, you can also, instead of clicking so this is the another way to um, to do the to show the graphs. You can also do some other, maybe suppose you want to find the power of this resistor. So now let me do this. So suppose, okay, maybe I want to know what is the power supplied by the voltage source. So what I can do is I need the voltage of this waveform, and I need the current of this waveform. So voltage, this is V1. So this is the current of V1, and this is the voltage at node V1. So I can also still, I have the opportunity of I have this activated this one, but right now the windows this window is activated, so I cannot see status bar here. But you can reconfirm it that this is in fact node 1. Node 1 multiply by static. I'll use static on the keyboard, and then I'll multiply by the current, which is of the voltage, and then I can say OK. You can see that now again there's another window which is appearing here, and it is showing me the watt, the power of this V1. So the power of V1 is that one, this one, and this color. You can click on this color, and you can see that this is this one, and this is 20 milliwatts. So the minus sign means that this power is delivered by the source. This minus sign is delivered. It is indicating. So if you want to replace this minus sign, you can say delivered by a verb, and then use 20 milliwatt as the power supplied by the source. So this is that's it about the. You can use any waveform. Suppose if you want to find this current here, you can subtract these two currents, and you can say that this is this current by using the KCL here. So, and you can also plot it.